All right, guys, we're up to example three, which is one where we're finding measurement errors. But I just want to talk about this very, very briefly first. Uh, just before we get to this one, we will be talking about accuracy and measurements. And we're going to be talking about a few things like precision, absolute error, upper bound, and lower bound. When you're measuring anything, there is a limit on the accuracy that you can have, whether it be your eyesight or the actual instrument that you're using to measure. If you're using a laser to measure the width or the length of something, that's going to be more accurate than if you're doing it by eye with a fiberglass tape measure that you normally use to measure off how far you've thrown a discus. Okay, so depending on the equipment and depending on your skill, the accuracy on measurement will change. But basically, precision is the smallest unit on the measuring instrument or the limit of the reading. The absolute error is the measured value minus the actual value, half times precision. And upper bound is measurement plus absolute error, and lower bound is measurement minus absolute error. Don't worry about those so much at the moment. You'll see them and they'll make sense. They'll actually be relatively straightforward. The main one is the precision, smallest unit on the measuring instrument. Then there is relative error and percentage error. We'll talk about them in a moment, but let's go and do this example. So here we go. Question A, and I'm actually going to do a lot of them up in this area up here rather than doing it down the bottom, just so that you can still see it all on the screen. So what is the length indicated by the arrow on this ruler? Now, if I zoom in any closer, you can see that it's actually pointing to the 38 millimeter mark. Now, obviously, you can't just zoom in on that when you're doing it in real life, unless you're like me and you have a magnifying glass on your phone that you have to use because you can't read anything anymore. Anyway, that is it. 38 millimeters. So now the next question is saying, what is the precision or limit of reading? So with this, what is the smallest unit that we have on there? Now, each one of these marks is 10 millimeters. If you go for those half marks, they're 5 millimeters, and each of the littler ones obviously is 1 millimeter. So our precision is 1 millimeter, which is pretty good. Now we have to find the upper and lower bound for each measurement. So to do that, if I just flick back a page, to find that upper bound, we need to do the measured value minus the actual value, and it's half times precision. So let's get that absolute error in there first. So let's have a look. If you think about it, if I was measuring this, if I was doing this one, I won't zoom in quite as much as I'd like. If I got a measurement that was sitting about there, so we're in between the 24 and the 25 marks. So it's somewhere in between there. Now, it might be exactly 24.5, but you're probably not going to read it as that. You're probably going to read it as either 24 or 25. Okay. Now, what we do in maths a lot of the time is we round up or we round down depending on how close it is to halfway. That's our rounding for decimal places and stuff like that. So if you think about it, this measurement that they've got here, that 38 millimeters that they've got, that could be, like, if it wasn't perfect, it could be, if it went anywhere up past halfway, we'd go 39. If it went below halfway, we'd go 37. But anywhere in between that 37.5 and the 38.5, we're going to round to 38 millimeters. I hope that makes some sort of sense. I'll explain it better later on as well. But what we're going to do is, with the upper and lower bound, we have to find our absolute error. So our absolute error is our half times our precision, which in this case is a half times 1 millimeter. So it is 0.5 millimeters. That's our absolute error. We're going to be out. Every measurement is slightly out. So we're going to be out plus or minus 0.5 of a millimeter. And that's fine. We're allowed to do that. So the upper bound, I'll just go UB, is our measurement, which is 38, plus that absolute, which gives us 38.5. And our lower bound is 38 minus 0.5, which gives us 37.5 millimeters. So that's our upper and lower bounds. Now, that is what I was just talking about there. When we're measuring it anywhere in between 37.5 and 38.5, we would just naturally round it to 38. So that's what we're talking about with that sort of thing. Okay, so between 37.5, which is our lower bound, and 38.5, which is our upper bound, our measurement lies inside that. All right. The next one is find the relative error. Now, relative error, I'm just going to call it RE because I'm lazy, is equal to our absolute error over our measurement. So we've just worked out our absolute error. Our absolute error is that there. That's our absolute error. So for this one, it's going to be 0.5 over 38, and that is going to equal 0.013. I did that on a calculator. Unfortunately, I don't have the calculator on the screen right now, but you would literally put that into your calculator and you'll get that. So that is question D. I should have put the questions, numbers, or letters next to them, but let's see. We're about to do question E, which is the percentage error. Now, percentage error is exactly the same. So percentage error, I'll just call it PE, is your absolute error over your measurement, and then convert it to a percentage by timesing it by 100%. So if we do that, we're going to get our 0.5 over 38. We're going to times it by 100%, and that will give us 1.3%. So that is our percentage error. And if you actually have a look at it, if you did that, if you multiplied that by 100, your decimal place would move 2 points and you get 1.3. So it is what it is.